Imagine a single, solid block of ice, vast, almost beyond comprehension. This was A-68A, a mega-iceberg larger than Luxembourg, born in July 2017 when it broke away from the Larsen Sea ice shelf. For a time, it was the largest iceberg on Earth, a titan set loose upon the seas. Its journey became one of the most closely watched sagas in modern oceanography. A-68A began a slow, perilous 3.5-year journey across the Southern Ocean, carried by powerful currents and relentless winds. It traveled over 4,000 kilometers through some of the wildest, most remote waters on the planet. As it moved north, the iceberg began to shed its mass, gnawed by warmer waters and carved by waves. Its final destination appeared to be the remote island of South Georgia, a haven for penguins, seals, and seabirds. A collision seemed imminent, threatening to disrupt this unique ecosystem and filling scientists with concern. The world watched via satellite as this drama unfolded, the iceberg a giant puzzle piece adrift from Antarctica. But what was happening beneath the surface? What changes was this immense injection of cold, fresh water causing in the ocean? For the first time, we had the technology to find out. The journey of A-68A was not just a spectacle, it was a unique scientific experiment set in motion by our changing climate. This iceberg's odyssey would reveal secrets about the polar regions and their influence on the world's oceans. And it all began with a single, monumental break. A-68A's drift toward South Georgia offered scientists a rare, natural laboratory. Never before had we been able to study the death of such a colossal iceberg up close. Its melting would release around 152 billion tons of fresh water, about 61 million Olympic pools, into the ocean in just a few months. The potential to alter the local marine environment was immense. Researchers from the British Antarctic Survey and beyond mobilized quickly, determined to gather data on this unprecedented event. This was more than just about one iceberg. It was a chance to understand a key mechanism in Earth's climate system. As mega-icebergs become more common with warming, this was a vital glimpse into the future of our oceans. By studying A-68A, scientists hope to improve climate models and predict the consequences of continued warming. The iceberg, a symbol of a changing world, was about to give up its secrets. The stage was set for a scientific mission unlike any before. The world's eyes and instruments were on A-68A. What would we learn from this frozen giant? Studying A-68A up close was too dangerous for humans, so scientists turned to autonomous underwater gliders. These torpedo-shaped robots glide silently through the ocean, collecting data on temperature, salinity, and chlorophyll, the foundation of the marine food web. Controlled remotely, they can patrol for months, sending data back via satellite. In early 2021, 2 gliders were deployed near the iceberg, navigating the turbulent, icy waters. They ventured into the plume of meltwater, gathering information from a place no human could safely go. By weaving in and out of the meltwater zone, the gliders built a detailed, 3-dimensional picture of the iceberg's influence. Their data provided the first-ever direct measurements from inside the meltwater of a mega-iceberg. Satellites showed the iceberg's size from above, but the gliders revealed the hidden story below the waves. They told us about the chemistry, temperature gradients, and biological response in real time. This marked a new era in polar science, expanding our ability to explore extreme environments. The robotic sentinels had opened a window into the unknown. The mission to study A-68A was a true test of ingenuity. The Southern Ocean is one of the harshest environments on Earth, with colossal waves, fierce winds, and shifting ice. Deploying robotic gliders in these conditions was a monumental challenge. The gliders faced constant threats from smaller icebergs and unpredictable currents. Pilots, operating from afar, navigated these robotic explorers through a treacherous maze, relying on satellite imagery and skill. Communication was often disrupted by weather, adding tension to every moment. South Georgia's remoteness meant no quick rescue if things went wrong. Despite these obstacles, the mission succeeded, yielding a data set of unprecedented quality. This project proved that with innovation and remote technology, we can reach into the heart of extreme events. The achievements of the A-68A team highlight the value of pushing scientific boundaries. The glider's data revealed the iceberg's dramatic impact on the ocean. As A-68A melted, it released a vast lens of cold, fresh water, creating a surface layer several degrees colder and less salty than normal. This buoyant cap disrupted the ocean's natural layering, preventing the mixing of deeper, nutrient-rich water with the surface. The water column became strongly stratified, with the meltwater dominating the surface and standard Antarctic seawater pushed deeper. This physical change was the first step in a cascade of ecological consequences, altering the habitat for all marine life. Over just 3 months, A-68A released enough fresh water to significantly alter the local environment. The findings provide a stark warning. If Antarctic ice shelf melting accelerates, these massive freshwater pulses could disrupt ocean circulation and ecosystems on a much larger scale. The iceberg's legacy is a transformed ocean, and a glimpse of what may come. The cold, fresh water from A-68A carried a hidden gift: nutrients. As icebergs form, they trap mineral-rich dust, especially iron, which is scarce in the Southern Ocean. When the iceberg melted, it released this dust, fertilizing the sea and sparking a massive phytoplankton bloom. The gliders detected a surge in chlorophyll, evidence of this explosion of microscopic life. The water in the iceberg's wake became a rich green pasture, visible even from space. This fertilization effect created a paradox. The iceberg disrupted the ecosystem but also fueled a surge in productivity. The bloom supported krill, which in turn fed fish, penguins, seals, and whales. A-68A became both a creator and a potential destroyer. Too much fresh water could still disrupt the ecosystem in other ways. Understanding this balance is a key challenge for polar scientists. The iceberg's paradoxical legacy is both bounty and risk. The impact of A-68A rippled up the food web, affecting the entire ecosystem around South Georgia. The phytoplankton bloom led to a boom in krill, the cornerstone of the Antarctic food web. Penguins, seals, and whales all benefited from this unexpected bounty. The iceberg's meltwater created a rich feeding ground, potentially boosting breeding success for the season. But had the iceberg grounded on the shallow seabed, it could have blocked foraging routes and devastated wildlife. Fortunately, A-68A broke apart and drifted past, sparing South Georgia from disaster. The event highlighted the dual nature of mega-icebergs, both creators and destroyers. Scientists now have a clearer picture of the risks and rewards these giants present. The near miss with A-68A offers vital lessons for protecting vulnerable wildlife hotspots. The story of A-68A is a lesson in planetary interconnectedness and a glimpse into a warming future. The calving of such a massive iceberg is part of a wider trend of polar instability. As global temperatures rise, more icebergs will enter the ocean, raising sea levels and altering marine systems. The A-68A study provides the first real-world data on how oceans respond to massive freshwater pulses. This information is crucial for refining climate models and predicting future changes. If these pulses become more frequent, they could disrupt global ocean currents, with far-reaching consequences for weather and ecosystems. A-68A is a wake-up call, showing how polar changes ripple across the planet. The journey of this one iceberg offers an invaluable preview of the challenges ahead. What happens in the remote corners of our world does not stay there. The fate of A-68A is a warning and a call to action. The mission to study A-68A marks the start of a new era in understanding our changing world. Underwater gliders have opened new frontiers for research, allowing scientists to monitor icebergs and ocean changes in real time. Ongoing research is vital to answer questions about how long these effects last and how marine life will adapt. The knowledge gained from A-68A is a foundation for future discoveries. The health of our oceans is fundamental to our own survival. Understanding these changes is one of the most critical tasks of our time. The story of A-68A reminds us that we live on a dynamic, interconnected planet. Only by listening to our world can we hope to protect it.